What do black holes eat? Contrary to what you may have seen in movies, black holes don't actually suck things in. For example, there are actually stars orbiting the supermassive black hole at the center of our galaxy. And they'll keep orbiting without falling in unless something else disturbs them. An object really has to fall right into the mouth of a black hole for it to be eaten. And the mouth, which we call the event horizon of a black hole, is tiny. If the entire Earth were to collapse and form a black hole, its mouth would be less than an inch across. But the movements of stars and galaxies do sometimes mean that stuff falls into a black hole's mouth. Sagittarius A*, the black hole at the center of our galaxy, mostly eats interstellar gas and dust that is drifting around. With telescopes, we have seen other black holes eating stars and even the gas from neighboring galaxies. Black holes can be messy eaters, as objects are being ripped apart. Some of the gas and matter can be flung off at high speeds. Sometimes, this is so powerful that it forms jets and winds shooting outwards at nearly the speed of light. And this can affect the galaxy containing it. These jets can blow apart nearby stars and planets. Or they can provide just the right amount of churn to create the ideal conditions for making new stars over millions of years. How were black holes discovered? The first inkling that anyone had about black holes came in 1930. When young astrophysicist Subramanian Chandrasekhar was mulling over the consequences of several recent discoveries, including Einstein's theory of special relativity. He calculated that all stars larger than 1.4 times the mass of our Sun would eventually run out of fuel and collapse, as lots of other theories about the universe. Black holes also seem to play a role in the formation of galaxies. It's likely our supermassive black hole has something to do with how we came to be here today. Some other things we can learn about the universe include understanding extreme physics and how stars and planets grow. Some supermassive black holes are extremely active, gobbling up stars amid swirling magnetic fields and flinging out jets of superheated gas and material. These systems are known as quasars. Watching this process can tell us about the physics of these extreme environments. It can also tell us about the conditions under which stars, planets, and galaxies are born, grow, and die, understanding how fast the universe is expanding, and therefore how it evolved. As we get more and more data on pairs of black holes colliding, holes and others have worked out methods to use them to calculate how fast the universe is expanding. This number, called the Hubble constant, is key to understanding the past, present, and future behavior of the universe, as well as the nature of dark matter and dark energy. Reconciling our major theories of the universe. One of the most fundamental questions in modern physics is how to reconcile quantum mechanics, which is the law for the very smallest particles in the universe, with general relativity, which is the law for the very biggest things in the universe. These two sets of laws don't quite match up, but black holes are the perfect place to explore the links between them. For example, Stephen Hawking theorized that the laws of quantum mechanics suggest that black holes have a very tiny temperature, which was surprising to scientists, since that implies some radiation is leaving the black hole. This has all sorts of implications for our understanding of physics. One such implication: black holes should eventually lose mass faster and faster over time until they explode. However, that will take trillions upon trillions of years to happen. So none of us will be around when it does. How was the first picture of a black hole taken? In 2019. People around the world were thrilled to see the first image ever taken of a black hole, and then, in 2022, an image of our personal supermassive black hole in the Milky Way. The bright ring around each one is created by material glowing very hot as it circles the black hole. This was the first direct image of a black hole ever taken. All of the other pictures you've seen are simulations or artist illustrations. These black holes are so far away that no normal telescope would ever be powerful enough to see them. You would need a telescope the size of the Earth. But scientists figured out that they could piece together images taken simultaneously from telescopes situated all around the Earth instead. One of these was the South Pole Telescope, run by a collaboration headed by the University of Chicago, which provided the view from the bottom of the Earth altogether. This network of combined telescopes is referred to as the Event Horizon Telescope. They next hope to create a movie of the glowing gas moving around a black hole as it's pulled in. Learn more about the quest to take the images here.